We're on topic 17, page 93. We're going to do 4 problems. Number 5, number 11, number 15 here, and number 17. So let's get started with question number 5. If 125 milliliters of a liquid costs $3.85, that's our given piece of information. How much would 500 milliliters of the liquid cost? So one way we can do that is to do the milliliters of A compared to the milliliters of B and set up the same ratio, dollar ratio. So here we have the milliliters of A and the dollar of A, so we can plug these into this and this. And then we have 500 milliliters for our B, and the dollar cost would be this here. So 125 is $3.85. 500 milliliters would be X. So we can cross multiply. 125X equals 500 times 385. So this is just cross multiplication. Then I divide this by 125 and I get X. And I divide the right side by 125 and I get 500 times 3.85 over 125. 125 goes into 500 4 times. 4 times 385 is 15.40. So the value of X right here is 15.40. So if we check the left side of this, it's 125 over 500 right here. That reduces to 1 over 4. Or if you want, you could just put this into the calculator and get 0.25. The right side is $3.85 over $15.40. And this also reduces to 1 over 4 or decimal 25. So the left side equals the right side. Now, we could have done this with an alternate method instead of you'll see right here we did milliliters of A to milliliters of B, dollar A, dollar B. We could set up an alternate ratio which would give us the same answer. Milliliters of A to dollars of A, milliliters of B to dollars of B. So 125 milliliters of A costs $3.85. So 500 milliliters of the B object would cost X. And if you cross multiply, you get exactly the same thing that we got here. And X would equal 15.40. So it doesn't matter how you set up the ratio. So here again we have a 1.8 kilogram object which weighs 270 grams on the moon. So this is like an Earth weight and this is a moon weight. So one thing we have to realize is a kilogram is the same as 1,000 grams. So if we have 1.8 kilogram, we have 1.8 times 1,000 or 1,800 grams. So what we're saying is 1,800 gram object on the Earth weighs 270 grams on the moon. So here we've got an Earth weight to a moon weight of the same object 8. 1,800 is to 275, and then the next part of the problem would be how much would a 175 pound astronaut, so then this is an Earth weight to a moon weight also, and X would be the weight of this 175 pound astronaut on the moon. So here's how we've set it up. Earth weight to moon weight of object A, Earth weight to moon weight of object B. This is my object A, and this is my object B, and obviously X is the moon weight in pounds of object B. So now I cross multiply. 1800x equals 170 times 175 times 270. I divide this by 1800 and I divide this side by 1800 to get x. So I get 175 over times 270 over 1800. Now I just repeated that here, so that this is unnecessary here. Actually, I should just remove it. And 270 over 1800, 90 goes into 273 times, 90 goes into 1800 20 times, and you get 3 times 175 is 525 over 20, which works out to be 26.25. Now you could just do this in your calculator. 175 times 270 over 1800 gives you 26.25. So now if we check the ratio 1800 to 270, we find that it's 6.666666. So we put a little bar over here to show the 6 is repeating. 175 over x here is 26.25, which is 6.66. So we took the left side of this, gave us this gave us this. The right side was this. We plugged in the 26.25 and we get 6.6. Repeating 6.6666. It just keeps on repeating. Left side equals the right side, so that this value is correct. Now alternately, we could have taken Earth weight to moon weight of A. So 1800 grams on the Earth is 270 grams on the moon. So the question is, what would the Earth weight of the astronaut be on the moon? So that would be my B. So it's just a different way of setting up the ratio here. Here you see one ratio, Earth weight to moon weight of A. And here we set up A on the numerator. So you can choose to do it whichever way you prefer. Cross multiply. 1800x equals 270 times 175. Divide this by 1800, divide this by 1800, I get the same answer I got before, 26.25. Number 15, a survey of 300 residents in a city included 210 who had cable. So we know out of 300 residents, 210 had cable. Accordingly, if there are 250,000 residents in this city, estimate the number who have cable TV. Well, this is a classic example of how we use ratios. So what we have set up is a ratio of residents to cable. 300 residents, 210 have cable. If there are 250,000 total residents, X would be the number who had cable. It's just an estimate. Cross multiply, 300X equals 210 times 250,000. We divide this side by 300, so we have to divide that side by 300. That way we get this. Now you can see that what I can do is reduce this to 70 goes into 210, 30 goes into 210 7 times, 30 goes into 700 10 times. So 7 times 250,000 over 10 is 175,000. You can do this on your calculator and you'll still come up with 175,000. So if you took a population of 300 and found within that city 210 were purchasing cable, you could estimate what if the city contained 250,000, roughly speaking, what number would have cable. And in this case, it would be 175,000. Of course, this assumes that your 300 residents don't represent all rich people or all poor people, but represent a cross section of the population of the city. So if we look at the left side, we get 300 over 210. This reduces to 10 over 7. Or if you just divide this, you'll get, and you round it off, you get 1.43. 250,000 over 175,000 right here. Because this is 250 over x, and x is 175, gives us this here, is 10 over 7. And that also, if you work that out on the calculator, is 1.43. Of course, you can take this, divide it by that, you'll get 1.43. Since the left side equals the right side, we know that the problem solution is valid. Okay, last one on page 93. Divide a 65 centimeter long piece of wire into two parts with a ratio of 4:9. So here we let the parts be 4x and 9x. 4x and 9x equal 65 because they're telling you let the two parts be 4x and 9x because they're in the ratio 4:9. So you say 4x and 9x, and that must equal the total of 65. So 13x equals 65. You divide 13x by 13, you get x. Divide 65 by 13, you get 5. So x is 5, 4x is 4 times 5 is 20. 9x is 9 times 5, which is 45. If you add these two, lo and behold, they add up to 65. And you check the ratio of the two lengths. One is 20, one is 45. And you could do 5 into 20 goes 4, and 5 into 45 goes 9. So 20 over 45 reduces to 4 over 9. The other method is to let x equal the first length. And then if you know the first length and the total length, then the second length must be 65 minus the first length, because the sum of the two must equal 65. So for example, if this was, let's say this was 30, this would have to be 65 minus 30, or 35. So once you know one, and the other is 65 minus this value. So we take the ratio of these two, x to 65 minus x, and we get 4/9. Now we cross multiply, and what do we get? 9x right here equals 4 times bracket 65 minus x. 4 times 65 is 260. 4 times minus x is minus 4x. Bring the minus 4x over to this side, get 9x. And you have 260, x is 20. And you can see here, that's the same as this answer here. Well, if one is 20, the other has to be 65 minus that value, 65 minus 20, which is 45. And if we check the solution, we put x over 65 minus x. If we look back at this equation right here, this is the left side right here. X over 65 minus x is 20 over 65 minus 20, which is 20 over 45, which reduces to 4/9. The right side is 4/9. Since the left side equals the right side, the solution is valid. So this completes page 93.